Good afternoon, friends. Today we are taking the session on flow past immersed bodies. So here we are discussing on lift and drag. So the flow past immersed body. So the body may be stationary and the fluid is flowing, or the fluid may be stationary or the body is moving. If you can take the example of the flow of air over the building. So building is stationary here. So air, the fluid is flowing. So if you take another example, flow of water over bridges. So bridge is stationary here, water is flowing. Now another example, submarines, ships and aeroplanes moving through water or air. So here the water and air so are stationary here, but the bodies are moving. In the earlier cases, so the bodies are stationary, but the fluid is flowing. If you take the third case, that is submarines and ships moving through water or aeroplanes moving through the air. So here the media, that is water or air, so that is stationary, but the bodies are moving. So these you can take the example of the fluids flowing over the stationary bodies or the bodies moving in a stationary fluid. Now coming to the force of drag and the force of lift. So for that I am taking the force exerted by a flowing fluid on a stationary body. Here you can take the example of the wing of an aeroplane. So, okay, or any other body here. So that is the body is stationary, but the fluid is flowing. So here u is the velocity in the direction of motion. Fr is the velocity which is making so inclination to the surface of the body here. So then you will have, okay, so the total force, so that is Fr, so that is exerted by the fluid on the body, which is inclined to the direction of motion. So that is splitted into the two forces, that is the drag and lift. So when you are asking to write the definitions of drag and lift, so the definitions are like this. Drag, so it is the component of this resultant force Fr in the direction of motion. So drag, so that is the irregular shaped body what is shown here, so will be dragged in the direction in which the force, this force, drag force is acting. So FD, so that is the horizontal component of this resultant force Fr. So here Fr will be taken as the inclined force to this surface of the body. So then we'll have the lift force. So that is the body will be getting lifted vertically upwards. So it is the component of Fr in the direction perpendicular to the direction of motion. So drag and lift. So drag is the horizontal force in the direction of motion, and lift is the direction of the force perpendicular to the direction of motion. So lift is the force which occurs only when the axis of the body is inclined to the direction of the fluid flow. If the axis of the body is parallel to the direction of the fluid flow, then the lift force will be called as zero. In that case, only the drag force will be existing. So now expression for drag and lift. So I am considering an arbitrary shaped solid body which is placed in the real fluid flowing with a uniform velocity u. So the liquid is flowing with a uniform velocity u. So you take a small elementary area dA here on the surface of the body. So then we have the force, that is P into dA, because we know that pressure is equal to force by area. So force is equal to pressure into area. So that is P into dA. So that is the pressure force acting perpendicular to the surface. Then we have the shear force. So shear stress is this tau. So multiplied by the area. So stress is equal to force by area. So force is equal to stress into area. So that is acting that is tangential direction to the surface. So theta is the angle made by the pressure force with the horizontal direction. So here theta is the angle made with the horizontal direction. So if this is theta, so then this angle will be 90 minus theta. So if this is 90 minus theta, because this line and this line are perpendicular to each other, so if this is 90 minus theta, so this has to be theta. So if this is theta, this line and this line are perpendicular to each other. So if this is theta, so this will be 90 minus theta. Now, drag force expression. So on the elemental area, we have the force, that is summation of the two forces here. So if you take the horizontal component of this PDA, so that is going from left to right, so that is having the positive sign here. Then this tangential force, that is shear force, if it is split into its horizontal and vertical component, the horizontal component is also going from left to right. So both of them carrying plus sign here. So writing them, so PDA into cos theta. So if you take the horizontal component of this theta, so that is cos theta, and the horizontal component of this force is cos of 90 minus theta. So that is what written here. Cos of 90 minus theta is written as sin theta. Now, so that is on one single elementary area. So we have drag force on the entire body. So it is integration of this plus integration of this. So this is called as the pressure drag, and this is called as the friction drag. So this is due to pressure force. So that's why called as pressure drag, and this is due to my shear force. So that is called as shear drag or the friction drag. So lift force. So on the elementary area. So if you take, so the lift force will be taken in the vertical direction. The vertical component of this is coming downwards, whereas the vertical component of this force is going upwards. So for this pressure force, the sign is minus as it is coming downwards. For this shear force, the vertical component is going upwards, so that is carrying plus sign. So that is what here it is shown. Pressure force minus sign, shear force plus sign. So this is for on single elementary area. So for the total lift FL, it is integration of these two quantities. Now the drag force and the lift force for the body moving in a fluid of density rho at a uniform velocity u are written as these two equations. These two equations are obtained from dimensional analysis that we will see in the next video. Thank you.